One of the most reliable rules of modern astrophysics is that the universe is expanding. Space itself is stretching out, meaning almost every galaxy we can see is steadily flying away from us. But right next door, there is a massive, terrifying exception. The Andromeda galaxy is actively defying the expansion of the universe, and it is hurtling directly towards the Milky Way. We know this by observing how light behaves in a vacuum. As this animation illustrates, when a light source moves towards an observer, its light waves compress, shifting towards the blue end of the spectrum. When scientists looked at Andromeda, they found a clear blue shift. It is coming right for us. And the sheer scale of what is heading our way is difficult to comprehend. Andromeda contains roughly 1 trillion stars, and at its center sits a supermassive black hole, packing the mass of up to 200 million suns. Closing the distance at hundreds of thousands of kilometers per hour, this galactic titan will reach our cosmic neighborhood in approximately 4 billion years. When we hear the word collision, our earthly instinct expects a violent, explosive crash. But the universe plays by a completely different set of physical rules. The truth is, this meeting of galaxies won't look like a high-speed car crash. It will be a slow, ghostly process, taking millions of years, where the two massive structures essentially phase right through each other. To understand why, look at this scale visualization. If we shrink our sun down to the size of a standard football and place it here, the absolute nearest star to us, Proxima Centauri, wouldn't even be in the same city. It would be over 6,000 kilometers away. Interstellar space is staggeringly empty. Because of these extreme distances, the statistical chance of any two stars actually hitting each other is practically zero. A trillion stars from Andromeda will slide past hundreds of billions of Milky Way stars without a single physical strike. But that doesn't mean the collision will be silent. While the stars miss each other, the massive, invisible clouds of drifting gas that sit between them will slam together. As the galaxies overlap, their combined gravity will violently compress these gas clouds. This pressure will trigger an intense wave of new stellar formation across the cosmos. Rather than a destructive apocalypse, this galactic merger is actually a creative forge. It will birth millions of new, burning suns, lighting up the sky in a massive starburst. The real violence, however, is reserved for the exact center of both galaxies. Deep in the core, the supermassive black holes of the Milky Way and Andromeda will inevitably find each other. Locked in each other's gravitational pull, they will form a black hole binary. The two monsters will execute a rapid, tightening death dance over thousands of years until they finally fuse into a single, unimaginable point of density. This absolute climax of the merger is so energetic that it will ripple the physical fabric of space-time itself, sending massive gravitational waves echoing out into the deep universe. We already know how these ripples behave. This is the LIGO Observatory in Washington State, where researchers use miles-long lasers to detect the exact kind of space-time distortions that a supermassive black hole collision leaves behind. Meanwhile, 26,000 light-years away from that chaotic center, our own solar system will be dealing with the fallout. As the galaxies tangle, the shifting gravity acts like a slingshot. Our sun and planets could be whipped to the far outer edges of the new galaxy, traded entirely into Andromeda's original stellar streams, or exiled out into the pitch-black void of intergalactic space. The physical planets will likely survive the ride intact, but our cosmic address and the star field we see when we look up at night will be permanently erased. This brings up an obvious question. Will any human eyes be around to witness the sky lighting up with colliding galaxies? The math gives us a harsh answer. In roughly 1 billion years, our own sun's core will heat up, expanding its energy output enough to boil away Earth's oceans. Long before Andromeda arrives, the biosphere here will be dead. But if we fast forward past the chaotic merger, the dust eventually settles. The distinct spinning arms of both the Milky Way and Andromeda will dissolve entirely. The stars will find a new equilibrium, forming a single, massive, glowing elliptical shape. Astronomers already have a name for this final state: Milkomeda. There is no technology, no shield, and no planetary engineering that can halt this process. The combined gravitational pull of over 1 trillion stars is an unstoppable absolute. Yet there is something deeply profound about this incoming reality. We live fleeting lives on a fragile rock, but our intellect allows us to peer into the dark, calculate the mass of invisible black holes, and accurately visualize the majestic reorganization of the heavens billions of years before it ever occurs.